Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 9 learners, and welcome to today's Natural Sciences lesson. My name is Mr. Sianda Madala, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, as you know, we are still in our term 3's work, exploring the knowledge strand, which is energy and change. And today we'll be looking at the topic of safety with electricity. And specifically, we'll be dwelling more on safety practices. Are we together? So now let's quickly look at our lesson objectives. Right. Remember that this is what we need to achieve when this lesson ends. So by the end of this lesson, we should be able to explain that parallel circuits can cause overload on main circuits, right? We need to be able to explain to the next person that parallel circuits can cause overloads on main circuits. Also, we need to be able to explain our circuit breakers, fuses, and earth leakage systems as our safety devices. And as well as we need to be able to describe the use of a 3-pin plug as a safety device to connect to the main circuit. Lastly, we need to be able to explain the danger and impact of illegal connections. And all this information is found under the CAPS document on page 75. Right, now let's move on to our pre-knowledge, right? Remember that this is what we have done in the previous grades and probably even in the same grade that you are in now, and they all lay a foundation to today's topic. Right, remember we started off with these topics in grade 5 when we were discussing what? Electric cells, right? We discussed electric cells in grade 5. Then we moved on to mains electricity in grade 6. We also talked about the national electricity in grade 7. Then also we talked about the energy transfer in electrical systems in our grade 8. Then, which is the very same grade that we're in now, grade 9, we talked about series and parallel circuits. And not only that, we also talked about resistance, right? So all these topics, they lay a foundation also to today's topic, right? They are a guidance to today's topic, right? We're going to draw some information from those topics, right, to make sense out of today's topic. Right. Now, without wasting time, let's move on to a baseline assessment where we are going to test our knowledge so far. We are going to go through the questions together. Then after that, I'm going to give you some time to complete this activity. Number 1 says, what is the difference between a series and a parallel circuit? Number 2, what is the advantage of a parallel circuit connection? Number 3, what is a fuse? Then number 4, what is an overload in electricity? Right? So it's 4 questions. I'm going to give you a quick 4 minutes to copy and complete this activity. Then after that, we shall mark together. Welcome back, grade 9s. I hope you were able to answer these questions, right? Because we have covered them in the previous topics, right? Let's see now how much you got from these questions. But before that, please do not forget to WhatsApp us on our WhatsApp interactive number, which is 079 578 2908. Are we together? So now let's do the solutions together now. Number one, what is the difference between a series and a parallel circuit, right? So the difference between a series and a parallel circuit is that a series circuit only has one pathway for the current to pass through, right? It only has one pathway for the flow of current. That is a series circuit. Then a parallel circuit now, it has more than one pathway for current to pass through or for current to flow through. Altogether, a parallel circuit has more than one pathway for the electric current to pass through. And please do not forget to mark your work. Number two, what is the advantage of a parallel circuit connection, right? So between the two, a parallel circuit connection has the advantage of what? Of when one component or resistor burns out, it can be bypassed, right? It can be bypassed so that it does not stop the flow of current to other components, right? So meaning what? So meaning that if one component in a parallel circuit burns out, the rest of the circuit can be able to still operate. Now, number three, what is a fuse, right? So a fuse is a safety device that has a metal wire that will melt if too much current flows through it, right? So it's a safety device that is used to control the amount of current entering a circuit. Number four, what is an overload in electricity, right? So an overload is when there is too much load, right? Too much load or too much current required, right? So resulting from too many components that can cause fires. That is what an overload is in electricity, right? So because it's too much of corrections here, let me give you a quick minute to copy down these corrections. Then after that, we shall continue with our lesson. Welcome back again, grade 9s. Now let's move on with our lesson. Starting off with the important terms that you are going to find throughout this lesson. Right. The first term that we come across there is overload. Right. So an overload means to exert too much load on or in something. Right. It means to exert too much load on or in something. Then we have circuit breaker. Circuit breaker now is a safety device that stops electricity from flowing when the current is too high, right? So underline the keywords there. It is a safety device. It stops electricity from flowing when the current is too high. Also, we have circuit board. Circuit board now is a unit that houses the circuit breakers, fuses, and earth leakage, right? A circuit board is a unit that houses the circuit breakers, fuses, and earth leakage. Then we have a fuse. which is a safety device that has a metal wire that will melt if too much current flows through it. We also have earth leakage. And an earth leakage is a system that allows extra current produced to travel safely to the earth, right? A system that allows extra current produced to travel safely to the earth, right? So now we've been talking about series circuits, parallel circuits, looking at the flow of electric charge, how it branches and how it differs from series and parallel circuit, right? And the advantages between the two circuits. Now it's time for us to focus on the safety practices when handling electricity, right? So now why do we need to be cautious of these practices? This is because of what? Circuits that have parallel connections can cause overloads on main circuits. Now let's take it back to our lesson when we were talking about parallel circuits, right? We said that with each and every branch that is added in a parallel circuit, the current does what? It increases, right? When you add more resistors in a parallel circuit, the current does what? It increases, right? So circuits that have parallel connections, they can cause overloads on main circuits, right? So the current increases every time another way or another pathway is added in that circuit. Are we together? So now, what is this circuit overload that is caused by these parallel connections that I'm talking about here, right? So it is when more current flows through the circuit than the circuit can handle. Are we together? So we say when we have an overload, we have what? More current flowing in the circuit than what the circuit can handle. So for example here, when too many devices are plugged into one power point, right? They can cause an overload, right? It is what the power point cannot handle, or it is more than what the power point can handle. Are we together? Right. So now this can be dangerous because now the wires, they heat up. As they heat up, they become very hot and they can cause what? Fires, right? As it is dangerous, we need to apply some safety precautions. Are we together? So the wires now, in their heating up, they can also melt and break the circuit. So for example here, looking at this picture, right? This is an overloaded circuit, right? This is more than wires heating up, melting, and also starting what? Possible fires, right? So there are measures that can be put or systems that can be put to prevent such from happening. Those are our circuit breakers, fuses, and earth leakage systems, right? We can use these as our safety devices to avoid what? Circuit overload, power surge, right? And possible fires. Right. So let's start off by explaining circuit breakers, right? So these circuit breakers now are our safety devices that stop electricity from flowing when the current is too high, right? They are there for a main purpose, right? To control the amount of current, right? When the current is too high, they stop the current from flowing. But how do they do that, right? Firstly, we find circuit breakers where in our houses, right? They are found in our houses, and we can see them in our circuit boards. Are we together? So a circuit breaker now, it has an electromagnet that breaks the circuit when the current is too high, right? So it is a type of magnet, but that has what? A coiled wire, right? To control the flow of electricity. Right. So there are different circuit breakers for different circuits in the house, right? So if you notice there in the house, there is that one for the geyser, the one for the lights, the one for the wall sockets as well, right? There are different circuit breakers to control the different amounts of current flowing through the components in the house. All together. So we have seen something like this in our houses. This is a circuit board containing circuit breakers. Are we together? These circuit breakers are the ones that now will help to control the flow of electric charge entering the house. Are we together? So what does it do now? It trips when the current is too high, right? And you have to turn it back on to allow the flow of current to enter the house and certain appliances in the house, right? So how does this work now? So this is how it works, right? So the current from the power supply enters the circuit through the live wire, right? Talking about power supply, we're talking about that mini station in our yards, right? Coming from the substations around the community and so on, right? So now the electricity travels from that mini power supply that is going to transfer this electrical energy into our houses, right? So the current from the power supply enters the circuit through the live wire. And now the current flows through a coil of wire with a soft iron core inside, right? As it enters there, when the current flows through the coil, an electromagnet is formed, right? There, where the strength of the electromagnet is directly to the amount of current flowing through the coil. Are we together? So this is how, right? As it receives current from the power supply, it enters through the live wire where it enters our circuit boards in our circuit breakers, right? Where the flow of current will be controlled. And in terms of when it is too high, the circuit breaker will break or trip to cut off the current from flowing. Are we together? So this is how it happens, right? The current coming from the power supply, as it enters here, it flows through this coil of wire with a soft core inside, right? So when the current flows through this coil, an electromagnet is formed, right? And that strength of the electromagnet is directly to the amount of current flowing through the coil. Are we together? So when this happens now, if the amount of current becomes too large or too high, the electromagnet now becomes strong enough to attract the side of the contact closest to it, right? So let's look at this diagram here, right? When the current is too high, right, the electromagnet becomes strong enough, right? This is the current flowing in. It becomes strong enough to do what? To attract the sides of the contacts closest to it, right? Looking at our diagram here we have our contacts, right? So as this happens now, the contacts are broken, right? They are broken to cut off the flow of charge from either side, right? So the contacts are broken and the current stops flowing, right? So in a circuit board in a house, that circuit on the board will trip and the switch will turn off, right? Let's look at this diagram again, right? So when this happens, when the current flows in here and it is too high, right, an electromagnet is formed, right, which will become strong enough to attract the sides of the contacts closest to it. When these contacts break, this is when now the circuit breaker trips or cuts off the flow of current, right? So when that has happened, when the flow of current has been cut off, someone has to reset the circuit breaker before the current will flow again, right? So now let's quickly test ourselves by writing activity 1. So number 1 says, what is the function of a circuit breaker? Number 2, what is the function of an earth leakage system, right? So 2 minutes quickly to copy and complete this activity. Then after that, we shall mark together. Welcome back again, grade 9s. Now I hope you had enough time to copy and complete this activity. Remember, we are still waiting for those responses, whether it's answers, comments, or any questions regarding this lesson on our WhatsApp number, which is 079 578 2908. Right. Now let's look at the solutions. Number 1. What is the function of a circuit breaker? Right? The function of a circuit breaker is to cut off electric current when the current flowing through it is dangerously high. Right? So a circuit breaker cuts off electric circuit when the current flowing through the circuit is dangerously high. Are we together? Don't forget to mark your work. Then number 2, what is the function of an earth leakage system? Right? So an earth leakage system allows excess current to flow safely to the earth, right? Preventing shock or damage to appliances because of high current flowing through the circuit, right? So now, yet again, let me give you another quick minute to copy down these corrections. Then after that, we are going to sail together with this lesson. Welcome back again, grade 9s. Now let's move on with this lesson. Right. So we mentioned 3 systems that you can use to avoid the dangers of electricity, right? Or as safety measures of electricity. We mentioned what? Circuit breakers, fuses, and earth leakage systems. Now we're moving on to fuses. Right. So a fuse is simply a device that is connected in series to the main supply, right? So that particular fuse, when the current becomes too high, the wire inside the fuse, it will melt and break the circuit. Are we together? The filament or the wire inside the fuse will melt to cut off the flow of current, right? So it completely disconnects the main supply to the house, right? So fuses are used as safety devices as well to avoid electric hazard, right? So this is what a fuse looks like, right? As you can see here, there is a wire inside, right, which is called the filament. The filament is the one that melts and breaks to cut off the circuit, right, to cut off the current from flowing through. Are we together? So now, how does this fuse actually work, right? So let's look at this now. Each fuse shows the maximum current it can carry before it breaks. Now let's remember, current is measured in amperes, right? So looking at this, right? Looking at this fuse here, it is of 30 amperes, right? Meaning it can carry 30 amperes. More than that, the current is too high for that fuse, and the filament in the fuse is going to melt and break the circuit, right? Cutting off the flow of current. Are we together? And once a fuse has melted, it has to be replaced so that the flow of current can continue, right? So there are different types of fuses, right? Looking at this one we normally see in our radios, we normally see in our cars as well, right? This one also is of 30 amperes, right? But the design is different from this one. So meaning what? Once the current exceeds 30 amperes, meaning the current is too high for that fuse or that component. Then the fuse will start to do what? The filament in the fuse or the wire will melt, cutting off the flow of electricity. Are we together? So now, let's move on to our earth leakage systems. So our earth leakage systems are also our safety devices that are installed in the mains circuit boards, right? So their job here is to do what? Is to allow extra current produced to travel safely to the earth, right? So it is mainly about what? Transporting or cushioning what? Extra current. Extra current that is provided where? In the circuit, right? So that it travels safely to the earth. Are we together? So they protect people from electric shock by redirecting the current in the circuit into the ground, right? So for example, when you have people working on a system or animals that may accidentally come into contact with a high voltage, they are protected from being shocked, right? Because it simply redirects the current in the circuit into the ground. So this is an example of an earth leakage system, right? It is installed in our main circuit boards, right? For it to be able to allow extra current that is produced in the circuit to travel safely to the earth or underground. Right. So now let's look at our activity 2, right? So it is 2 questions again. It says, why are fuses and circuit breakers important? Then number 2, how do we know that the current was too high when we examine a fuse? I'm going to give you a 2 minutes again to copy and complete this activity. Then after that, we're going to do corrections. Welcome back again, grade 9s. Now let's look at the solutions. Number 1 was saying, why are fuses and circuit breakers important, right? So fuses and circuit breakers stop the flow of current when it is dangerously high, right? When it is too high for the circuit, right? And they prevent the possibilities of fires or damage to electrical appliances and devices. You mark your work. Then number 2, how do we know that the current was too high when we examine a fuse, right? So we know by looking what? At the fuse, right? because of what? The thin wire in the fuse would have been broken because it melted as a result of the high current. So the thin wire in the fuse will be broken because it melted as a result of the high current, right? So another quick minute now to copy down the corrections. Then after that, we are going to the last part of our lesson. Welcome back again, grade 9s. Now let's move on with this lesson. Right. As our lesson objectives have stated that we're going to describe what? The use of a 3-pin plug. Right? So now, as we know that all appliances need a plug to connect them to the power mains. Right? As you look at our washing machines, they have a different plug. Look at your radio, it is a different plug, right? It may be a 2-pin plug or a 3-pin plug, right? But all appliances need a plug to connect them to the power mains. Are we together? So the most basic plug has only a live wire and a neutral wire, but this now is unsafe, right? Hence we talk of the using of a 3-pin plug. Are we together? So this one is unsafe. So a 3-pin plug now provides a live wire, a neutral wire, and as well as an earth wire. Are we together? So a 3-pin plug looks something like this, right? It has an earth wire that has what? Somehow these colors, green and yellow, right? Then it has a neutral wire on the left hand side where it has what? A blue color and a brown wire, which is our live wire. And looking at this brown wire, it is connected to a fuse, right? Which will automatically melt what? The filament in the fuse to cut off the flow of current when the current is too high. Are we together? So a 3-pin plug simply has a live wire, a neutral wire, and an earth wire, right? And it is the safest plug, right? So let's look at how this one works. Right. So the earth wire now in the cord of an appliance, right? Such as a kettle, a washing machine, a television, or any 3-pin plugged what? Appliance. Are we together? So it is connected to the metal case of the appliance, right? So the earth cable has almost no resistance. Altogether, there is more flow of current through it. It has almost no resistance. So this means that if the metal casing of the appliance becomes electrically charged due to a fault, right, the charge is safely discharged to the ground. Are we together? So without an earth wire, the appliance would become charged with electricity when there is a fault, right? So this is the earth wire that we are talking about instead of these 2-pin plugs that look something like this, right? Instead of these 2-pin plugs that look something like this, right? That only have a live wire and a neutral wire. Are we together? So this 3-pin plug provides safety with this earth wire, which is going to discharge what? The electric charge when there is a fault, it discharges it to the ground, right? And without an earth wire, the appliance will become charged with electricity when there is a fault, and which can cause what? Possible fires as well. Right. Now let's look at the dangers of illegal connections. Right? So illegal connections to a main supply can be dangerous as wires are not connected properly and not connected safely. So, right? So this can cause dangers in the household, in the community as well as a whole, right? Because of illegal connections, right? So the voltage in the power lines is much higher than what is needed inside a house. So with illegal connections now, right, there is not so much knowledge on electricity, right? Hence the connections are hazardous, right? So the voltage in power lines is very high, right, than what is needed inside a house. So there is no control of the amount of current entering into the house as well. Are we together? So as a result, people can be electrocuted while making or using what? An illegal connection, right? And as well as in the household as well, our people can be electrocuted by the devices that they are using. Are we together? So illegal connections are regarded as energy theft as well, right? Because the electricity used is not paid for. So this is an example of illegal connections, right? As you can see here, there are many wires branching to different houses here, right? All connected to this one power source, right? But they are connected illegally, right? And the voltage coming from here is too high than what is required in the house. Are we together? Which can cause what? Damage to property as well. Which can cause what? Some fires in the community or in some households altogether. Right. Now, without wasting time, right, let's quickly look at activity 3 now, which is our final activity for today, right? So let's go through the questions together. Number 1, use the diagram of a circuit breaker to explain how a circuit breaker works. Number 2, Jerry is going to change the fitting on a wall plug. What is the first thing he must do before starting to change the fitting? Number 3, look at the picture of a fuse and sketch a diagram of a fuse and explain how it works, right? And don't forget to label the thin wire in the diagram. Then number 4, what is the purpose of an earth leakage system, right? So there's so much to explain here. I'm going to give you a full 5 minutes to copy and complete this activity. Then after that, we will do the corrections together. Welcome back, grade 9s. We are still waiting for those answers, comments, or any questions on our WhatsApp number that is on the screen, right? So number 1 was saying, use the diagram of a circuit breaker to explain how a circuit breaker works. Number 2, Jerry is going to change the fitting on a wall plug. What is the first thing he must do before starting to change the fitting? Number 3, look at the picture of a fuse. Sketch a diagram of a fuse and explain how it works. And do not forget to label the thin wire in the diagram. Number 4, what is the purpose of an earth leakage system? Right? So now let's look at the solutions. Right. For number 1, a circuit breaker has an electromagnet that breaks the circuit when the current is too high. An electromagnet is formed when an electric current travels through a coil around a bar magnet, right? And as well as the current through the coil increases, the strength of the electromagnet also increases. So when the current is too high, the electromagnet is strong enough to attract what? The ion catch or the contacts closest to it, right? So the contacts, the ion catch holds the contact point in place so that the current flows, right? So once the ion catch moves towards the electromagnet, the contact between the 2 points is broken and electricity can no longer flow, right? So that is how a circuit breaker works, right? That is the answer for number 1. Right? Then number 2, Jerry must switch off the main circuit breaker first before he changes what? The socket, right? He must first switch off the main circuit breaker, and because it will stop the electricity from flowing, right? And prevent an event of him getting shocked. Then number 3, remember, a fuse is a device that has a metal wire that will melt if too much current flows through it, right? So that is the definition of a fuse. That is a diagram of a fuse, and this is the label for the thin wire that will melt, or the filament in the fuse. And number 4, an earth leakage system allows extra current produced to travel safely to the earth, preventing people who are working on a system from being shocked, right? So now, let us quickly take another last minute to copy down these corrections. Then after that, we are going to wrap up our lesson. Welcome back again, grade 9s. Now we are moving on to our WhatsApp slide, right? So now I see that there is no interaction on our WhatsApp, right? We've been waiting for those questions on our number, which is 079-578-2908, right? So seemingly there is no interaction on our WhatsApp. We are going to pass this slide, right? But next time, do not forget to interact with us. There is a very good team behind the scenes that is going to assist you in your answers, questions, or any comments regarding the lesson at that point in time. Are we together? Just a reminder, the WhatsApp number is 079-578-2908. So now let's summarize what we have learned for today. So today we were talking about safety with electricity and dwelling more on the safety practices, right? So we said that now, because of parallel connections, right? Parallel connections can cause overloads on main circuit, right? As they cause the overload on main circuit, the current increases, right? As the current increases, right, it increases because of what? Another pathway added, or what? One part of the circuit also being broken, having the current having to travel to other parts of the circuit. Are we together? Also, a circuit is overloaded when more current flows through the circuit than what the circuit can handle. So for example, when too many devices are plugged into one power point, right, they can cause an overload because it's more than what the power point can handle at that point in time. Are we together? Also, we said that this is dangerous, right? It is dangerous because the wires can become very hot and they can start fires, right? So the wires can also melt in the process and the circuit can break. Are we together? So also we said that we need to use safety devices such as circuit breakers, fuses, and earth leakage systems to control the amount of current flowing through, right? To be able to cut off the current when it is too high, right? So a circuit breaker, it is a safety device that stops electricity from flowing when the current is too high, right? And the circuit breakers are used in circuit boards in our households. So also we said that a circuit breaker has an electromagnet that breaks the circuit when the current is too high, right? So there are different circuit breakers for different circuits in the household, right? So now, to mention some of the examples, when you look at the circuit board there, right? Some are even labeled that this circuit breaker is for the geyser, this circuit breaker is for the lights, this circuit breaker is for the wall socket, the sockets around the house, this circuit breaker is for the air conditioner, and so on and so on, right? So also a fuse as one of our safety devices, it is connected in series to the main supply, right? And a fuse has what? A wire inside, or the filament, which will melt and break the circuit, disconnecting it to disconnecting what? The main supply to the house. Are we together? So the wire in the fuse melts when the current is too high. And each and every fuse has an amount of current that it can handle before it breaks, right? So it shows the maximum current it can carry before it breaks. So meaning if that fuse is written 30 amperes, for example, and the current is more than 30 amperes flowing through, it means it's going to do what? To cut off the current, right? And once a fuse is melted, it needs to be replaced. So also we said that an earth leakage system allows extra current produced to travel safely to the earth, right? So for example, people who are working on a system or animals that may come into contact with a high voltage line, they are protected from being shocked by earth leakage systems, right? So we also highlighted the use of a 3-pin plug for safety, or as a safety device, right? So we said that a 3-pin plug has a live wire, a neutral wire, and an earth wire, right? So we also highlighted what? The dangers of illegal connections, where we say that illegal connections to a main supply can be very dangerous as wires are not connected properly and safely, right? So I hope if you have enjoyed today's lesson, let's meet again when we are talking about national electricity. So you know what to do now. Go home, study on this topic so that when we come back here, it is an easy teaching and learning process, right? So from me to you now, thank you and goodbye.